Hi everyone, welcome to today's webinar, How to Kickstart Security and Compliance for your AWS, Azure, and GCP clouds. My name is Ryan McCurdy. I'm on the marketing team here at Lacework, and I'll be your moderator today. Before we get started, a couple of housekeeping items. This webinar is being recorded and will be sent to everyone after the event. This webinar is also meant to be interactive, so please submit any questions via the questions box and we'll answer them at the end. With me today, I have Dan Hubbard, our Chief Product Officer here at Lacework. So thank you for joining us today, Dan. And with that, let's get started. Over to you.
Great. Thanks very much, Ryan. I think we've got a pretty interesting topic here. We're going to talk all about cloud security, some of the trends we're seeing, and then, of course, how Lacework can help provide some solutions in our service for folks. So first, let's talk about a little bit of the landscape that we are in right now. I think we're in the midst of a major security technology and market transition. And typically, these don't happen that frequently, but when they do happen, they kind of demand a number of pretty dramatic changes from a security delivery perspective. And any major security technology shift or big market shift is typically predicated, I believe, in kind of three key areas. The first one is there has to be a big shift in the way that IT and technology is delivered. The second is that there typically is a large, diverse attack surface. And then lastly, there has to be the beginnings of in-the-wild breaches and or in-the-wild attacks that are happening. And certainly, I'm going to dive into why I believe these are true, with the public cloud today. But a good example of one that didn't necessarily come to fruition would be something like mobile or iOS and Apple devices, where it was a big shift in technology, but there really isn't a large, diverse attack surface. It's controlled. The hardware is controlled. The app store is controlled, and therefore there wasn't a major security technology shift that happened during that. So let's drill into these in a little bit more detail. So the first one really is about the shift in technology. The way I think about cloud is that SaaS was kind of the first wave. SaaS was all about how do I use my existing applications that I used in premise or traditional way, but I use it as a service in the cloud, software as a service. This could be CRM with Salesforce or my productivity suites with Google Suites or Office 365. And this was really driven by ubiquitous connectivity and the ability to do my job or for people to do their jobs from anywhere on any device at any time. And this first cloud wave certainly had a lot of threats, a lot of challenges, and it created a lot of very large successful companies like Okta, Duo, and OpenDNS, and Zscaler. We're talking about billions of dollars of market cap that was created, helping secure that first wave of cloud transitions. The next wave is actually arguably a lot more interesting in that, first off, it's a lot earlier. This is all about how do I move my workloads and my infrastructure and my applications to the cloud, either via IaaS or PaaS, or in most cases, a combination of both. And how do I, first off, where do I move those? More than likely, the top three come into play here, AWS, GCP, and Azure. But furthermore, we're looking at today, somewhere between 15 to 20% penetration in this, and it's a way bigger number. And it's growing faster than SaaS grew. So it's a major, major market shift in technology, and I think it's very hard to argue against that. The second is that there is a very large, diverse, addressable attack surface. So the cloud providers, the cloud service providers, AWS, Google, and Microsoft have something called the shared responsibility model, which quite simply says, hey, they're responsible for the security of the cloud. This is the physical data center, the hardware, the hypervisor, everything down below that, the host operating system, and then, of course, the network that is being delivered. And then everything else below that is, by and large, the responsibility of the person that is living within that ecosystem. And that is very broad and very diverse. There's literally thousands of APIs that can be used. There's thousands of services that can be used. And, of course, when you're delivering applications, there's N plus, thousands of ways to do that. Gartner predicts in 2022 that 95% of all cloud security problems and failures would be the fault of the customer, so not the cloud service provider. And I like to say, how do you determine the shared responsibility model? It's basically, if you can configure it, you need to secure it. So you can't configure a lot of the things, obviously, above the responsibility line, like the physical access, the hardware, but you can configure all of the APIs, all of the paths, all of the IAM roles, and of course, all of your applications that you're deploying. And another part of shared responsibility that doesn't get talked about near as much is what I call the shared irresponsibility model. And this is within companies, and this is probably one of the biggest challenges that we're running into today. And this is that there is becoming division within the development, the people that are running this infrastructure, and most of the infrastructure today is built with infrastructure as code. You don't get a physical box or a piece of hardware that gets baked in and security looks at it, says it's secure, and gives it back. You actually do this all programmatically. And then on the other side, you've got a group of security professionals that are saying, hey, the developers are just insecure, and we can't keep up with this, and we need to put these guardrails in place, or we need to put these roadblocks in place. And of course, the developers are saying, hey, the application's everything, this is critical to my company, and security can't slow us down. So this is sometimes referred to as, the DevSecOps movement, whatever you want to call it. It's really about how do I make the developers more security savvy and the security's more developer savvy. And how do I, in the meantime, when I'm not, those two aren't synced, there is a very wide addressable attack surface around configuration problems, visibility, and issues that can appear because of that. There's becoming a lot of attacks in the wild. This industry is yes, sometimes driven by FUD that is delivered via a number of different ways in media and social, but a lot of these are real, and a lot of these are things that should be concerning from a security perspective. Things like data leaks, data exfiltration, hijack resources. There's a number of vulnerabilities now that are out there that are specific to the cloud, and you need to be aware that there are things that are happening in almost weekly that are getting talked about publicly, and of course there's a lot more that's happening privately. These are very broad sets of attacks. They span across a number of different areas, whether it's things as sophisticated as container escape vulnerabilities, insecure APIs, RCEs, remote code exploits, injection attacks, crypto mining we see a number of times within customers' environments, and of course data exfiltration and mistakes that are breaches that are happening via mistakes. And then there's always the the insiders and the developers, and of course people that you want to know of that actually have privileged access within your networks. So the problems that you need to solve kind of from an organization perspective aren't really that much different in the public cloud, but the operating model and the way that you need to think about these is dramatically different. There's container security and workload security, things like host-based intrusion prevention and visibility at a runtime level, application visibility, the ability to look at your infrastructure and go back in time and understand if there was a breach, what happened at what time. You need to think about the accounts. The accounts are essentially the entrance into the door of the infrastructure. Think of IAM and the way that your programmers and developers are writing to APIs and are writing and logging into the infrastructure, kind of like the keys to your data center. This is, the way that they get in, and there is no physical data center, of course, that you own. So the way that you get in is by authenticating to their accounts and then using those accounts and those services. And then a lot of this is driven through a compliance and an audit framework. And compliance is becoming a lot more popular because it's a very easy way to think about the problem. Hey, I'm delivering my application in a different way. I need to make sure that I'm doing best practices. My customers are asking me, is this application that I'm delivering or the service secure? How do they know their customers' data is secure, that their data is going to be secure? And how do I comply to whatever standards that I'm beholden to, whether it's SOC 2, PCI, HIPAA, name your favorite standards board, when I operate within the public cloud. And the security choices today are very challenging. It's very, somewhat early, but unfortunately, what a lot of the incumbent vendors have been praising, early on is, hey, I've got an incumbent technology that was not designed for the public cloud. Take that and put it in the cloud. So this is sometimes referred to as cloud washing, which, in many cases is taking things like a physical hardware appliance, quote unquote, virtualizing it, and then saying it's available, just use it in the cloud. So there's a lot of the legacy tools aren't custom or purpose fit for the cloud, and you got to think about it very differently. It's not about the same tenants that you had in private data center. So using legacy tools is somewhat challenging because they're not really designed to work and operate in the cloud. There's a huge amount of open source tools that are available. Things like OSX, OS Query, Security Monkey. I mean, there's probably, it seems like every 2 weeks there's some new open source project that's out there, and that's great. That really shows that the demand is there and the community is providing a lot of value in these tools. And there is definitely, there is value in these tools, but you do have to manage them. You have to know what the cost of ownership is of them. You have to be comfortable in the fact that you can scale with these tools. So there is a bunch of other things that you need to think about besides, oh, I'll just use open source and we'll be good to go. And then lastly, there is point solutions. So, the segments or the sectors, the feature sets that we span across here are typically compliance, audit, configuration control, host and container security, and then analytics across all of these. So you can run into a scenario where you have multiple point products, and we know that this is very challenging from our former security life and pre-cloud, in that you run into this complexity curve where you have all these different products that aren't put together and aren't glued together, and that just adds all kinds of issues from an efficacy and efficiency and of course the cost of management standpoint. And why is it hard for security to operate in the cloud? Like when we talk about infrastructure as a service and platform as a service, what are some of those key challenges that we face as an industry that make it more difficult? And what are the changes, the big things that are just very dramatically different? The first one is that it's harder to get visibility into the infrastructure itself. You can't drop 12 boxes in line, your 5 defense in depth boxes that each get a chance to look at the packet and then go from there. That's just not near as possible. The network is becoming very, very hard to look at. Most of the stuff is encrypted now. Most of the details of the network are encrypted. There's things like service meshes that are happening. So it's not just encrypted at the SSL layer, but certainly it's becoming encrypted at another layer above that, perhaps IPsec or something above and beyond that. There's also the workloads are ephemeral. Quite often a lot of the servers themselves come and go. It used to be very simple. You could ask a customer, how many web servers do you have, or what's the IP address of your web server? That question or the answer to that question is becoming very, very hard. The answer now is, well, it depends. I don't know how busy our website is, or I don't know how big our data warehouse needs to be right now. It contracts and expands as I need demand. And furthermore, I have IP addresses changing all the time. So the IP address of a machine is becoming less of a signal of identity to know where do I hunt or look at information. So you need to have a high degree of automation in detecting these threats and risks. And lastly is security cannot be a place where you are blocking the application pushing and the development of applications, because that is in many cases key to the business success. So security must run at the speed and the scale of DevOps, which is, I think, a critical, kind of leave with this, is like if you are not running at that speed and if you are providing roadblocks, it's more than likely that you're going to go around or you're not going to get that visibility or that access. So what is Lacework? So Lacework, of course, is the name of our company. It's also, of course, the name of our service. So we provide a number of different features and functionalities that I'm going to go through here. I'm going to walk through kind of a high level how it all works and puts together and what the value is. So first and foremost is we provide automated security for your cloud workloads. That doesn't matter if they are bare metal, if they are an AMI within AWS or or a virtual version of Google Compute. We also can operate deep within a container, and we provide container security, and we provide a level of visibility and threat detection for Kubernetes. We also have a high fidelity threat detection system, and really, the goal obviously of the system is to not just give you visibility, but of course at the end of the day it's critical that you get detection for threats and a low signal to noise ratio of what's going on in my infrastructure. Because really this is about telling you where there are risks and threats that you need to be triaging in order to make sure your infrastructure you're delivering is not being compromised, or that you don't have things that are happening that you don't want to happen. We run 100% as SaaS ourselves, so there is no hardware you need to deploy. Of course, there's no virtual boxes you need to deploy, and it is designed to work at scale. So you don't really, in terms of you as a customer, it doesn't, really affect you what version we're on, how many servers we have, what our infrastructure looks like. It, just like most modern sets of infrastructure, expands and contracts as we have more load from more customers. And it is also a unified security platform. We straddle a number of different areas and give you one location where you get all of your detections, threats, and analysis and compliance and audit from one product and one service in the cloud. So if you really oversimplify it, there's kind of two main areas. The first one really is Lacework for workload security. Today we have customers in AWS, Azure, and Google's cloud. We also have people that straddle either multi-cloud or hybrid. So, the definition of multi-cloud is that you are operating in more than one public clouds, and the definition of hybrid is that you are operating in one of the public clouds and a private cloud, whether that's rack space or your own data center or some, OVH, doesn't really matter, but you're operating your workloads in that environment, whether they're on bare metal servers yourself or whether you're doing containers or Kubernetes that span private and public cloud. The value we provide is host intrusion detection. We do runtime container and Kubernetes security, so we have deep understanding of the labels and tags and Docker and, of course, Kubernetes specific things like namespaces and pods and nodes within your environment. We also do file integrity monitoring, which is a critical aspect for compliance. Things like PCI need file integrity monitoring, looking at your system, understanding if there's changes. And then lastly, we provide threat and incident investigations across all of the data that we're collecting. And of course, I'm going to dive into a little bit more details on this in a bit here. The second area is really about account security. And there are a level of users within the workloads. So these are typically SSH users, or the people that are connecting to your applications, if you allow that. But then there's accounts. And as I said before, accounts are really the IAM accounts and roles, which allow your developers and your administrators to provision, modify, and access all of your infrastructure within AWS, GCP, and Azure. So first and foremost, we provide real-time compliance monitoring across all of those clouds. So not only do we provide a dashboard which tells you how am I doing from a compliance perspective, whether it's PCI, SOC 2, or best practices, but also we will give you real-time alerts if anything goes from compliance to non-compliant. And for your auditors, of course, you want to have these reports that say, here's how we're operating, here's we're passing this number of audits, or here's the things we've looked at and we've suppressed or don't care about, and here's the things we really care about that we have fixed or are fixing. But also a lot of the compliance threats and risks are the beginning of a larger problem. So the ability to take a workload event and pair that and map that to a account security or an IAM event is really, really important. Because a breach may come from an account security problem or a risk, but it may turn into a workload event where maybe the user gets access to a machine or provisions machines or installs bad software or backdoor or something on a workload, and you want to be able to pair those two together through a threat model in some way. Of course, we don't just look at kind of binary things. We also have the ability to do machine learning and anomaly detection across your configurations. So we do build a baseline of good, and then we're tracking that baseline over time to understand if there is things that we need to alert you on based off of the state change over time. And that allows us to look not just at your IAM and access of your developers, but also what services are they using, provisioning, and modifying. And we look at that over time, but of course you can also go back in time to see if there's things that were potentially a risk after you find out about a breach or something in the present. The product is very easy to deploy. It's incredibly simple to manage. As I said, it is a SaaS service. Most customers get provision across all of their accounts and their workloads within a couple hours. All you need to do is give us, of course, account access. You typically read access, of course, to your AWS, Azure, and GCP. And then you have to roll out our sensor agent, which allows us to look at the containers and or your hosts. And the way you do this, we have a number of different ways to do it. You can bake it into an AMI directly. You can bake it directly into a container. We've got scripts and deployment mechanisms for Kubernetes. You can do it via Puppet, Chef. There's any recipe system, or just an install script, which allows you to push it out. Once you push it out, the system itself just starts collecting data from all of your accounts, all of your infrastructure, and then, of course, from all of your workloads. I'll go into a bit on the next slide, but quite simply, once you have it deployed, you don't have to do anything. The system itself will start understanding what your infrastructure looks like and will start creating alerts and baselines and give you access to that data right within a single pane of glass. And then there's an event API where you can pull the data out and start triaging and looking at the events from there. And if we dig into that with a little bit more detail, at the very top, you could think of this as a sensor or a data collection network where we're collecting data across all of your workers or your containers and your endpoints, but also across things like CloudTrail and the net equivalent in GCP and in Azure. So we're collecting all that information, and today we have more than 1.5 trillion kind of pieces of data or entities of data, and we add approximately 24 billion new additional ones per day. And this isn't just across customers' data, but this is also across honeypots we have, crawlers that we deploy, and things that we have that our research team uses in order for us to collect information about modern threats here. The types of information we're collecting are what APIs are you using? What services are you using? Do you use KMS or do you use EC2? Are you using BigQuery? Are you using, SQL hosted service within Azure? We're collecting all the data about your IAM. Where are people logging from? Where do they log in from? When they log in, what do they do? We're also collecting from the machines all of your applications, all your processes, and all of your network traffic, along with your user logins. So we're collecting this massive amount of information, and when you think about the efficacy of any system, the amount of data you collect is critical to the models and the way that your efficacy works. So we have a massive amount of data, literally petabytes of data that are coming in that's very dynamic and changing, but it is specific to servers and users' behavior about how you use your servers and your infrastructure within public cloud. From there, all of that information and data comes to of course, a system in the cloud, which allows us to not just look at known threats. So a known threat, for example, could be something like a piece of intelligence we know. Is this a known bad domain? Is this a known bad IP address, a known bad hash? Or is this a known bad behavior that we've modeled across all of the population over time? So, for example, should users be able to SSH from 2 different countries at the same time to do different behaviors? Is that even possible? So there's known bad things that we look at. There's all kinds of intelligence that goes into that is built off of the Lacework labs and our research team, but also from third-party feeds and the community and partnerships we have. The next is that we have a technology called the polygraph. The polygraph uses machine learning models to understand what is normal within your environment. So this is not unique to the entire population, unlike the known threats. This is unique to your environment. is it normal that Dan logs in from this country at this time? And then when Dan logged in from this country at this time, that changed, so he logged in from a different city, but what did he do when he logged in? Did he provision a new service, like a new region? Did he install a new application that connects to the network in a different way? How do we put all those pieces together? And the polygraph allows us to do that. It builds a literal graph, or about a dozen different graphs across a number of different areas, like your applications, your network, your user behavior, your IAM roles, your users and accounts, your assumed roles, your services, whether it's a storage service like S3, or a compute service, like GCP, or a Kubernetes service like GKE. So it graphs all this data, and that really allows us to identify the unknown. And then lastly, we have the ability for you to write your own customized and configure the rules. So this allows you to say, okay, there's a bunch of known bad things you know about, and there's a bunch of machine learning stuff which is really cool, which builds this behavior baseline, that's awesome, but there's things that I want to specifically look for. So the system itself allows you to customize that through policies and through rules. So all this is happening in the background, this is happening in near real time. We're collecting all this data, it's going through all of our threat models, and then of course, the end result is that you need to make sure that this data is getting to you. So obviously we're a SaaS service, but now we need to actually get the alerts to you. So once it comes into our system, we have a number of different abilities and partnerships and integrations with modern workflow systems, whether it's Jira, we have a Slack integration, PagerDuty, Splunk. We could drop it into a data share in Snowflake, into Elasticsearch. There's a number of different ways to get of course, email to get the system out. Because quite frankly, unless you're hunting for data, you're not logging into our dashboard. You're coming into our dashboard because we've told you that there's an event that has happened, and now you're going to triage the event. And efficacy is critical here. So what you don't want is a massive signal-to-noise problem. So a lot of security systems that are doing blanket things that are just saying, hey, here's all this stuff that changed, or here's something I think might be bad, or a customer writes a rule that's too broad, that's going to create a lot of noise. And typically what happens is you have alert fatigue, you get too many alerts, and then you just start ignoring things. So our goal, of course, is to deliver the best fidelity of data to you. So when you come back into the dashboard to triage the alerts, or when we're delivering the data to you, either via an alert or via our API, that you have enough context to now triage the alert in as fast as amount of time as possible. To give an idea of some of our larger customers at the very top, we're collecting a neighborhood of about 1.5 billion events per day, and that gets down to about 1 to 1.25 high and critical alerts today that they triage. So we take a massive amount of data and drill it down into what really matters. And then, of course, we have a portal which allows you to do forensics, incident handling, triaging, the enterprise UI. There's a query, there's a search query where you can go log in and, of course, say, hey, tell me everything about this user in CloudTrail, or about this user that logged in and used BigQuery, or tell me everything about this compliance violation that I had. And then we have an event RESTful JSON API, which allows you to pull information out of the system to go triage it in another system that you may have, whether it's Jira or a SOAR tool or something else. Lastly, and of course not least, is we also have the ability to do orchestration. And we really believe that the future of operating in the public cloud and with things like Kubernetes, the great thing is there's a lot of APIs and availability to do things like orchestration versus enforcement. So enforcement in our world is things like, hey, I have an application that's running, I want to just kill that process, or I want to kill a packet on the network. That's what we believe is kind of the way things used to be. Now, and that's kind of neutering a security incident. We believe that really we now have the ability to do complex orchestration. Things like deploying Lambda functions to say, hey, if we see a risk like an S3 bucket open, I'm going to orchestrate my system to say, close it. Or if we see a user that has a weak password or doesn't use multi-factor authentication, we're going to turn that on. Or if we see a machine in my Kubernetes cluster that may be infected, take it out of my cluster, or move that pod offline. And the ability to do that, the ability to like literally unplug servers was really, really difficult before the advent of things like Kubernetes and auto healing and auto scaling within the cloud. But now we have the ability to do that, which is really exciting. And we really believe the pairing of the ability to look at your services, your accounts, the network, and the application level stuff is critical, because the ability just to look at the network is diminishing over time, and you're going to be stuck with just a 5-tuple of source IP, destination IP, and port. And what does that really mean anymore? What you really want to know is what user ran that application, what was the application, and how do I logically look at my application? So we take a large set of things and we put it down into a logical set of items, like this is your web server, or this is your database tier, or this is your load balancing tier. There might be 5,000 of those, there might be 50. We don't really care. We're looking at them logically. And you can't do that without an application-specific view of your applications, your processes, and the network together, combined with, of course, the services and the APIs. So the big kind of customer use cases, or sometimes the places where people get budget. The first is in IaaS and PaaS configuration and compliance for AWS, Azure, and GCP. The second is in cloud server or cloud workload or container compliance. Part of PCI and HIPAA and SOC 2. Things like FIM, things like IDS are part of that. Things like visibility over time and logs of what my servers are doing is part of that. And then lastly is runtime threat detector and container detection and container security. How do I know that I haven't been breached? How do I detect and prevent breaches from happening? How do I pair things like my query logs and my API logs and my IAM account data with my workload data? And how do I do that all within one interface? So the benefits, I think, of this solution, what we're hearing from our customers, is really about helping the developers and the security teams come together. On the security side, it's all about automation. It's all about how do I move from a traditional security and perimeter-based defense in depth model to an automated security model for the cloud. How do I create accurate and actionable events and triage those events with the right amount of information at the right time? And how do I do that at scale? On the DevOps side, and in almost all of our customers and all of our prospects, DevOps is a critical aspect of this. They typically are the ones that are helping provision the accounts. They're typically the ones that are helping provision the agent itself. They're very involved either from a budgetary or from an influence perspective because they're running all the infrastructure. It's their applications. So this allows DevOps to be secure and run their high velocity application deployment. It also is built in a way that doesn't get in the way of development. So we don't have inline things that will block anything. We're a detection system that allows you to orchestrate, and it's really engineered for cloud. As I said, there's no appliances or hardware that you need to do, and there's no right sizing of the system itself. It just is built to operate at cloud. We have a number of great customers that span all kinds of segments and sectors. The exciting thing I think about the public cloud and securing the public cloud opportunity is it's everything from small little startups in San Francisco through to Fortune 10 companies. It's about cloud native companies that are less than 10 years old that grew up in the cloud and understand the complexity of building infrastructure at scale. But it's also about big enterprise companies that have been around for 30, 40 years that are building new applications and moving new services and migrating existing services to the cloud and understand the net benefit of deploying things in public cloud versus building your own data center and managing a bunch of client server apps within a static environment. So we've got all kinds of customer use cases, of course, on our website, and more than happy, obviously, to share those offline, or you can go to lacework.com to see those. We also, because we are a SaaS service, it's very simple to try. We're firm believers that, everybody should try the solution. I could talk about bits and bytes and, cloud, machine learning, blah, 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 all day. But the reality is you got to try it. Let us prove it to you. So we do have a 30-day free trial. You can deploy to as many workloads and as many accounts as you want. You could put it in production if you want. You can put it in dev, QA, stage, one of your BUs, all of your BUs. That's really up to you. From there, we will give you a 30-day readout report, which will tell you, and you can view obviously all this in the portal, all of your risks, and essentially give you a free threat assessment of what's happening across all your AWS, GCP, and Azure accounts, and all of your workloads within, whether they're deployed as containers, in hybrid, in private data center, or with things like Kubernetes, or of course bare metal. And that's totally free. Just go to lacework.com/free to do that. So with that, I'm going to look at some of the questions we've had coming in, and I think we got a bit of time here, which is good. The first question says the cloud security solution-based attachments are not there; they're not available. Actually, I noticed that myself, but it's kind of confusing. If you move your mouse over that part, you can click on it. If you still have problems, please just email us and we'll send them to you directly. The next is that do you have remediation workflows that work with various OEMs? So I don't know which OEMs in particular you're talking about, but we are providing remediation workflows in the form of code. So we're giving Lambda functions that allow you to take those and do whatever you want with them. You could deploy them in whatever infrastructure you have or in whatever way you want, because we don't believe that you're going to give us access to do that. Like the idea of giving another provider full right access to change your infrastructure is a little bit scary right now, and typically people aren't looking at doing that. I've got another question here. What types of threats can you detect within containers? So some examples are, we can tell you which containers are running as privileged containers. That is a bit of a risk. You want to kind of diminish privileged containers within your environment. We can tell you and give you visibility into east-west traffic from container to container, or of course north-south, containers that are connecting out. We also give you runtime access to the applications and what containers they're running on. So for example, we can tell you which containers are open to the world on what ports, and that's interesting, but what you really want to know is what applications are running on those containers and how are those logically associated. So we could say things like, hey, you have a Docker container which has 50 containers, but that is all logically inside of one Elasticsearch cluster that happens to be open to the internet, and it may be vulnerable. You need to go address that. We also have an entire dossier and a set of cards around Kubernetes. So we don't just give you visibility into Docker and other container systems, but we also have a full dashboard for Kubernetes. So Kubernetes, our agent understands things, all the labels and the tags within the containers, things like your pods, your nodes, your clusters, your namespace, and we have polygraphs and dashboards which allow you to drill into that. So we can tell you risky things like my API server is open to the internet or my management server is open to the internet. And we can tell you things like, oh my gosh, people are connecting to my API server over the internet, not through my VPN or not through a secured channel where the developers are using things like Kube Controller or Kube CTL that sometimes is referred to as. Our Kubernetes system, just to dovetail into another question, we support EKS, GKS, and of course, if you want to roll your own Kubernetes service and manage it yourself, we also support that. I think the last question I have here is how do people typically find budget? I addressed this a little bit, but it often starts with compliance for cloud and audit. That's usually the thing that most non-technical people understand. Say, hey, we're operating in public cloud. We have to adhere to PCI and SOC 2 compliance. Our private data center is SOC 2. How do I do that in public cloud? And that can mean a lot of different things depending on the customer, but typically compliance is a good way to unlock budget. Of course, security sometimes is a trailer of a breach. So, we do unfortunately talk to some customers that say, hey, we had a breach, Bitcoin mining was happening in our infrastructure. It was kind of a bit of an egg on our face, situation. We can't have that happening anymore. We need to know about risks and threats and prevent those moving forward. Or, hey, I heard about this other company in the news, or I saw that this is happening. Well, I want to make sure this doesn't happen to me. That's kind of the breach scenario. And the last one is really, people are starting to really line item and start thinking about, hey, I'm moving to the cloud, or I've moved to the cloud. Can I create a cloud security budget, which is essentially a line item that maps to how I deploy my systems across the infrastructure. In a lot of environments, it also starts with visibility. So compliance, configuration, audit, breach, cloud budgets. A lot of it just comes down to, how do I know what's going on? It's always amazing sometimes when we get this deployed and we have security people are like, whoa, I didn't know we actually deployed in, the Japan, data center for AWS. I didn't know, we have, 2,000 servers in this one, US West East for GCP, or I didn't know that my private data center connected to my, SQL backend in my public data center. So it's all about visibility, of course, in the beginning, and then from there it's about understanding the application, understanding the threats that are provided with that. So with that, those are a great set of questions. This recording will be available, and there is contact information, of course, available to you. If you have any direct questions that you have for me, my email address is Dan, just D-A-N, @lacework.net. You can feel free to email me directly. Otherwise, I hope you have a great day, and we will be in touch. Thank you.